Hello guys, welcome back to another video. Today our topic is about what is enzyme specificity and substrate selectivity. Specificity is a property of the enzyme and describes how retractive the enzyme is in its choice of substrate. A completely specific enzyme would have only one substrate. The specificity of the Syrian proteases is usually not very high since they have similar active sites and act through the same proteolytic mechanism. Consequently, a single Syrian protease may act on various substrates, although at different rates. How the substrate fits the active side of the enzyme is of crucial importance to the outcome of the enzyme substrate reaction. The bond to be cleaved must have a specific orientation relative to the amino acid chains of the catalytic thread. The most important factor regarding the fit of a substrate for an enzyme is the amino acid sequence around the bond to be cleaved. Trypsin cleaves amides and esters of the basic amino acid arginine and lysine. Thrombin has a similar preference but is more specific for arginine than for lysine. Selectivity is a property of the substrate and indicates the degree to which the substrate is bound to and cleaved by different enzymes. The best measure for selectivity is given by the ratio K cat Km. Synthetic substrates are considerably smaller than the natural substrate and can usually be cleaved by more than one enzyme. Example: synthetic substrates are not completely selective. The explanation for this is that large substrates such as fibrinogen not only interact with the active site but also with exterior domains of the enzyme. Such interaction allows substrates to discriminate between different serine proteases and fibrinogen thus become highly selective for thrombin. Selectivity tables. The selectivity data of the table have been compiled to permit the investigator to understand how a contaminating enzyme would influence the enzyme is substrate reaction under study. Another way of expressing this is to say that the table shows the relative reactivates of two or more enzymes, one particular substrate. The table should be read horizontally. Each row represents the reactivity of a substrate designated for use with a particular enzyme indicated to the left relative to other relevant enzyme. Examples: the set of data in the top row shows the relative reactivity of the thrombin substrate with various enzymes. All the experiments were performed using the same buffer. Example: the one most appropriate for the reaction between thrombin and chromogenic substrates. In addition, the substrate concentration was always the same, or 2x came for the reaction of chromogenic substrates with the thrombin. The concentration of the different enzymes are given in table 2 and are related to the plasma concentration of the corresponding enzymes. The reactivity of chromogenic substrates with thrombin measured as the time dependent increase in absorbance is given the value 100%. The actual value of is given in brackets. The reactivities of chromogenic substrates with the enzymes FXA, FXLA, APC, plasmin, single chain TPA, plasma, kallikrein, and C1s have then been related to the reactivity of chromogenic substrates with the thrombin and proved to be 5, 540, 5, 560, and 2% respectively.